Kubernetes-friendly and open source, CockroachDB helps developers build and scale apps with fewer obstacles, more freedom, and greater efficiency. Discover CockroachDB, the most highly evolved database on the planet. Get started for free and get a free t-shirt at cockroachlabs.com/InfoQ.
Open Policy Agent, OPA, is a policy engine. It allows you to decouple policy-making decisions from policy enforcement across your entire application stack. Or put more directly, it allows you to write code pulling from things like pod definitions in, say, Kubernetes, and write logic, think rules, that you can then pass those decisions back to an upstream, to an app to actually act on. That's the decoupling decisioning from enforcement part. While I'm personally most familiar with OPA in the context of Kubernetes, Open Policy Agent doesn't just stop there. OPA has agents available spanning the front end, the back end, from K8s to applications that might run in a cluster, things like Kafka or maybe Spring-based apps. It can plug into the service mesh. It can plug into API gateways, even CI/CD pipelines it can plug directly into. Whether running in K8s or even securing an SSH on a Linux box, OPA is a versatile policy engine with a large ecosystem that is designed for the cloud native space. And we'll actually dive into that a bit in the podcast. And it truly delivers on the promise of policy as code. Today, we're speaking to two of the creators of OPA, Torin Sandall and Tim Hinrichs. Hello and welcome to another edition of the InfoQ Podcast. My name is Wes Reisz. I'm one of the co-hosts for the podcast. If you like what you hear on the podcast today, be sure to check out QCon Plus. QCon Plus is a software conference that we run that's focused on senior developers and architects. This is an online edition of QCon with the environment that we live in today. Again, still focused on senior developers, still focused on architect. This edition of the conference will be held over 2 weeks in May. It'll be May 17th through the 28th, and it's really built for an online audience. So it'll be an extended format where you can do just a couple hours a day across those 2 weeks rather than fully committing for a full part of your day like you might for an in-person conference. It's going to feature 16 tracks with people like Tammy Bryan Butow, Principal SRE from Gremlin, Randy Schaup, Chief Architect at eBay, Sergey Fedorov of Netflix, along with engineers from Red Hat, Google, and Financial Times in London, and many, many more. So check it out if all this makes sense or it's of interest to you. As I mentioned today, we're talking about Open Policy Agent with Torin Sandall and Tim Hinrichs. Torin is the VP of Open Source at Styra, and Tim is their CTO. Both are co-creators of the Open Policy Agent project. Today on the podcast, we're going to discuss OPA. We're going to talk about some of the problems that OPA has been solving and why they came up with the idea to attack it like this. We're going to talk at Rego. That was the rules, the policy, the language things that they're actually able to control these decisions coming through and how they attack this problem. We're going to talk about the ecosystem. We'll talk about K8s. We're going to talk about a lot of things, and we'll see where the whole conversation goes, but we're going to dive into OPA over the next half hour. As always, thank you for joining us on your walks, runs, and commutes. Torin, Tim, welcome to the podcast.
Thanks, Wes. It's great to be here.
Thanks, Wes. Looking forward to the chat.
Prepping for this podcast, I probably watched 6-7 different presentations that two of you have done over the last couple years. So my first question is, over the last 2 or 3 years, how many times have either one of you asked the question, how many people in the audience have heard of OPA?
I feel like there's a correct answer to this question.
Every single one I watched.
7?
I think I watched KubeCon from a couple years ago, and you could see more hands going up as we got closer. So it's gaining mainstream. It's good. Congratulations.
In the early days, those questions were super important because we would be on the spot at some of those talks deciding how much content we were going to go into, how deep it was going to be. And so it's been fun to see that over the years that at the beginning, we had a deep dive session. We're like, pivot, we're going to do an intro session because we could just see the audience. But then obviously now we've got it like bona fide intro and deep dive sessions. So it's certainly fun.
Kind of start this off. Tell me, what does Styra do? Where are you all from?
We're all from Styra. We have really 3 things that we do day in and day out. The mission of the company is to provide a unified solution to authorization for the cloud native ecosystem, right? And there are 3 things we do. Obviously, we started OPA, donated to the CNCF, and continue to maintain it and shepherd it. The second thing we do is that we offer support. So if anybody's using OPA and they need some help, we're happy to help there. And then the third thing we do is that we have a commercial product designed to help operationalize OPA in an enterprise. So if you're trying to roll out OPA within an enterprise across many teams and you'd like some help with that, we're happy to help there too.
When I set this podcast up and wanted to do this, I did it, and we'll talk about it here in a bit because the CNCF graduation, I wanted to kind of hit on it. It was good timing for all that. But I was really only thinking about OPA from a Kubernetes context. I didn't realize that OPA could be used across the entire stack. Is that a common thing that you find when you're talking to people?
We definitely find that people pick up OPA for a particular use case, right? They have some concrete problem that they're trying to solve in their organization. And because, Kubernetes is so hot and so many people are, like learning how to manage it right now, that's often one of the first places that they come into OPA from. But, once they've used it to solve like admission control, like putting guardrails into Kubernetes, they pretty quickly realize how broadly the project can be applied. And they start to kind of like venture out. And so they might venture out into other places in Kubernetes. Like we see people using it to do just plain old authorization in addition to admission control in Kubernetes. But, they might go elsewhere, right? They might start using it to scan their configuration files during CI/CD. They might use it to enforce policies in SSH, at the host level, right? Or they might start to inject it into their APIs, right? And to control access at runtime. So we typically see people start with one use case, maybe it's Kubernetes, but then they learn and they see how broadly it can be applied throughout their environment.
So double click into that a little bit. When we say it can be broadly applied across the application stack, I'm familiar with authentication, authorization, access, getting into things, but what does it mean to be able to apply OPA across the entire application stack? What does that actually mean?
Yeah, so we like to use that term, across the stack because it's great for us as engineers because that's how we think about, building software. We think of a stack. You've got a CI/CD pipeline that's kind of part of the stack. And then you've got the cloud platform. Maybe you're using, maybe it's public cloud. Then maybe Kubernetes there on top of that. Maybe you're using a service mesh. Then you're running your applications, and those applications are also using databases. And then the application itself has a gateway sitting at the front. So, when we talk about across the stack, one of the things we've tried to do with OPA is make it possible and even easy to integrate OPA into really any kind of piece of software that people are using for building and running modern software systems, cloud native software. And so that's what we mean. Like the idea of applying OPA across the stack means that you can integrate it really wherever you want. And that was one of the design criteria around OPA, that integrating it with other pieces of software was incredibly important. And making it able to work with any piece of software was also super important. So what we never did with OPA was say, we're going to write a bunch of Go code that makes OPA know what a Kubernetes pod or an ingress is. We're not going to add a bunch of code that knows what an HTTP method or a path are. Instead, we'll make it general purpose and agnostic. And so therefore, we can apply it to all those different elements of the stack, things that we've never even seen or heard of before. That's kind of why it works. That's why we like to say it applies across the stack, because it is easy to integrate. And moreover, it has been designed to be domain agnostic.
So why is it easy to integrate? What are some of the design decisions that make it easy to integrate across the stack?
Yeah, so I think that kind of goes back to what Tim was saying, which is that OPA itself is not tied to any, domain-specific data model, right? So it's not tied to HTTP, it's not tied to Kubernetes, it's not even really tied to like JSON or anything like that. Basically, you can feed it arbitrary structured data, typically JSON, and then it can evaluate that data against rules that have been written for it. Right. So OPA itself is not tied to any of those technologies. All it sees essentially is structured data, JSON coming in as part of the query, structured data being evaluated by rules, and then structured data being generated by those rules representing policy decisions, and that being kind of sent back for enforcement, right? OPA itself is completely decoupled. The rules you write bring meaning to that data. They understand that that data represents a Kubernetes pod, or it represents an incoming HTTP API request. But on its own, OPA is completely decoupled. And so because it's so decoupled, it's really easy to plug it into different systems. In order to ask OPA for a policy decision, or in order to extend and enhance a system to use OPA for policy decision making, all you have to do is execute a single API call to say, give me the policy decision for this input data. And so the job of the integrator is really just to gather the data that's potentially relevant to a policy decision, and to supply that as input. So that's something that anybody that's familiar with the system that they're integrating into will be really comfortable doing.
Yeah, totally. It makes sense. The ecosystem's pretty wide, Torin. I know there's a whole bunch of different integrations that are there. What are some of the more popular ones, or just give me kind of an idea of the breadth of the integrations that are out there?
We have integrations obviously for Kubernetes. We have integrations for service mesh projects like Envoy. We have integrations into different that integrate with CI/CD systems. It really goes everywhere, right? Even down to Linux PAM, for example. And so if you go to openpolicyagent.org, you can see tutorials for the top ones that we've seen on the page. So we think Kafka, Envoy, SSH, Terraform, Docker. And then we also have an ecosystem page on the website. And that ecosystem page, anybody can contribute to that. So if you go there, you'll see, I don't know how many there are on there now, but basically anybody that builds an integration can basically add a little card to that page, and they can link off to talks or blogs or videos about that integration. And that's a great place for people to go and discover like what's available, whether they're interested in API gateways or service mesh or orchestrators or databases, you name it, programming languages. That's the place to go to find an integration with OPA.
So let's use this, I call it the whiteboard of our mind because it's a podcast and we don't have a whiteboard. But let's kind of draw this kind of pictures out. So you've got this box that you feed JSON data or some different data to it, that there's this like engine that's going to be able to do something. What are the boxes that are in this flow from, say, I don't know, a web server that's going to allow some kind of access or something? What are the major boxes in this piece that I need to kind of understand to understand what OPA does?
So that's a great question. So, the way we draw it is pretty much what you've already described, which is you have a service. It doesn't matter whether it's a gateway, it doesn't matter whether it's a Kubernetes API server, it doesn't matter whether it's an SSH PAM module in Linux. That piece of software just decides at some point in time that it needs a policy decision, an authorization decision. The simplest version is then it sends an HTTP request to OPA that says, that's a post, I think technically, post or a get, and then it says, as my payload, here is a JSON object. Give me a decision back. Now, OPA, its responsibility is to be able to make that decision all on its own, and then return that decision as another JSON object back to the caller. So the interface is fairly simple. It's an HTTP post to OPA to get an answer, and the answer that comes back is another JSON object. Whether that's the Kubernetes API server, or it's the service mesh, or it's the PAM module, that response needs to go ahead and look at that JSON and force that decision. But nevertheless, it is OPA that is making the decision.
And then as an integrator, if I'm using Java, I might have an intercepting filter that then looks at that and either blocks or doesn't. I have the choice on how to actually integrate that into my application.
Yeah, exactly. So like the response that comes back is generated by the policy, and that response might just be a simple yes, no, right? Saying yes, allow this, continue as normal, or it might be a no, block this, send an error back to the client. Or it could be something more interesting than that. It could include an error message, right? It could include like the reason why you're not being allowed to perform the operation, right? And so then it's up to that little enforcement module to do something with that. But at the end of the day, that's the model.
Very nice. So I literally spent, we were telling you before the podcast started, I probably spent a good 5 years of my life writing different things for SSO that kind of sat in the stage. What's the genesis of the project? What made you all kind of think, let's abstract out this into something that is universal and we can use across the stack?
That kind of goes back to the origin of the company Styro, where we work, right? So in the early days, the company started, there were a couple of us at VMware. We'd come in through an Azure acquisition. And so we were talking to a number of financial clients at the time. And what they had told us was a story of hey, we've got all these applications, all these pieces of software, and they built a unified solution to policy and authorization. But they were like, no, we don't want to do this. This is not what we do. We move money around. We're a bank. And so they said, well, you know what, how about you go off and build this for us? And so at some point, then we went ahead and started Styro with this idea in mind that as organizations embrace cloud native, they're going to see the same problem of policy and authorization. They're going to have to solve it across the stack, right? Authorization has been around forever, but now everybody's embracing all this new technology. And so they're going to have to deal with authorization. And because of the cloud native world, it's so ephemeral, it's so dynamic, it's so oriented around microservice architectures that we knew that the authorization problem was going to be far more compelling and challenging than it ever has been in the past. And so that was when OPA came into existence. Just hearing this from end users and then executing on that.
Very nice. So let's talk about Rego. Actually, inside there, we're getting this data and you're making decisions, the rules that you're actually writing. When I saw this, it kind of reminded me of other aspects of my programming career. It reminded me of kind of drools, of rules engines that I might have been writing to do something. It reminded me of maybe even writing a DSL on top of that. Is Rego a rules engine DSL? Was it designed to be like that, or is that just a byproduct? How does it kind of fit in this space?
You can think of Rego as a rules engine. What Rego is it's a high-level declarative language that's based on decades of research into policy systems. It embodies certain ideas that make it really useful for these kind of more modern cloud native systems. So it has first-class support for operating on deeply nested structured data, JSON, basically. So it basically gives you the primitives that you need to write down the logic that controls who can do what in a system, right? And so it's designed to allow you to take something that would normally be written down on a wiki or in a PDF that says, thou shalt do X, Y, Z in order to ensure compliance. And it lets you basically put that into code. So it embodies this idea of treating policy as code without going all the way to the extreme of a standard programming language, which is not something that non-technical folks can write. It's not something that technical folks want to write when they're dealing with policy, right? Policies are these like organic things that change all the time. And they really just need to be able to focus on the data that's in the system that the decisions have to be made based on and the logic, right? You don't want to be thinking about, sockets and errors and data structures when you're thinking about policy. You want to just think about what is the logic that I need to express to ensure that I'm compliant, right? And so that's what Rego is sort of designed to help you do.
You just said something that I want to hit on a little bit, and that's that cloud native. As I was working in the past, I was always doing authentication authorization. It was always the ingress, the point that I was coming into an application. When you say this is designed for cloud native, how are applications designed in a different way today that we really need to have a tool like this that can plug in, like for east-west traffic, for example? How is it cloud native different than maybe the monolithic style of applications that was using authentication authorization before?
I'll reference Netflix in this talk. It was funny. I think the first major public talk of OPA was by Netflix way back in, I think it was Austin, if I remember right. So that was numerous years ago. And the use cases they had was exactly this. It was controlling east-west traffic. They wanted the security team to be able to put certain policies in place, and they wanted all the developer teams to be able to control at a lower level the east-west traffic for all those applications. And the story that they told was the same one that we were telling, but I'll tell it as if they told it, which was that, in this microservice world, one of the things that you realize is very different from the monolithic world is that for any end user request, you've got many more hops over the network from one microservice to the next in order to sort of assemble the end user's customer payload, answer the question the customer asked. And when you move to that kind of microservice architecture, because you have all those additional network hops, what you don't want to do from an authorization point of view is have a separate service that each and every one of those hops over the network has to go and ask for a decision from in order to get a decision. Because it'll double the latency, it'll double the number of network hops, and in so doing, it'll greatly reduce the overall availability of the service. And so what they wanted to do, which is what OPA was designed to do, is push all that authorization logic to the edge. So have, in this case, OPA running on each and every node in the service so that however many microservices you have just as many copies of OPA, except all of those OPAs are running on the same server as each and every one of those microservices. And so by doing that, you've simultaneously decoupled policy from that underlying microservice. So you're not hard coding the policy into the service itself, but you're also getting roughly the same availability and performance as if you had left it in the code.
Makes sense. So we started talking about Rego before I asked the cloud native question. Let's come back to it for a second. When you talk about it being kind of a declarative language, talk a little bit more about it. I have some experience where I had to write Lua, for example, in Nginx, and there were some constraints that I had, like no loops and things like that. How extensive, what kind of things do I have to live by with Rego? Are there any characteristics of the language that I need to be aware about, like not making outside calls to services? What are some of the things that I need to think about when I'm writing Rego?
That's a good question. I mean, the language at its core is actually really simple. It basically just lets you write down a bunch of if-then statements effectively that are just simple Boolean conditions, basically, right? It's like, if these conditions hold, then assign this value as the decision, right? So if the method is get and the path is /salary and the user is from HR, then allow is true, right? So that's really what the language does at a high level. It just lets you write down these if-then statements over structured data. But, in order to do that, there's like things you need, right? So you need to be able to obviously like refer into that structured data. So one of the things that's sort of at the core of the language is this ability to reference data and kind of dot into it as you just kind of naturally would want to do. Because we're dealing with collections of data, in a Kubernetes pod, you might have a collection of containers that need to be analyzed, right, in order to come up with a policy decision. And so it gives you the ability to iterate and search across that data. And because you're dealing with all kinds of different data, you might need special functions to operate on it, right? So for example, if you're working with web APIs, you might be ingesting JSON web tokens, in order to make the policy decision. So we've got functions that help you like verify signatures, decode the token and extract the claims and all that kind of stuff, right? So the language comes with a bunch of primitives that basically make it easier to write these kinds of policies. And then OPA itself implements a bunch of performance optimizations to ensure that policies execute quickly and efficiently. And then it provides you with, tooling so that you can kind of really treat it as code, right? So it gives you like a test framework and a REPL and, all that kind of stuff.
I think I said loops when I was talking about Lua, but I meant like if blocks and things like that. There's some constraints when you have if. So are there any limitations, I guess, is really where I was going with Rego. How do you maintain performance, I guess, when you're in the request path with some of these decisioning things that you have to deal with?
One thought here at a high level was that the way to, I sort of think about this on a line of expressiveness. So like at one end of the spectrum, you'd have like RBAC, right? Role-based access control and attribute-based access control, maybe ACLs, maybe IAM. At the far other end of the spectrum, you have programming languages, right? Fully Turing complete, do whatever you want, call it, right? Open socket, sit in infinite loops, that's fine. Rego's in between those two. It is more expressive than all of those RBACs and ACLs and IAM. In some part because it does support looping and iteration natively. But it is less expressive than the programming languages and the Turing complete programming languages. So it sits in between, and that was kind of the goal. That's also why it can be applied to so many of these different use cases. Like Kubernetes requires you to dig down through deeply nested structures, but also to do like in-level deep looping as well. So to be able to just express the policies that people seem to need, you do need that kind of thing that's broader and richer than the standard sort of access control languages. What I didn't answer yet, though, was how does that help with performance? And Torin's already articulated that there are a number of different performance optimizations that we do, some of which are possible only because it is less than Turing complete, right? If you've got a perfectly, you've got a programming language, what kind of optimizations can you do? You're certainly limited there. And by dropping down that expressiveness, that enables a whole new class of performance optimizations typically. So one of those is like rule-based indexing. So it'll go ahead and like statically analyze the rules that you write and build a data structure that minimizes how many of those if-then statements get evaluated on any particular request that comes into OPA. And so we see that being used very heavily for like the microservice case.
Makes sense. Let's talk specifically about Kubernetes. How does OPA integrate with Kubernetes?
Yeah, so OPA is most often used as an admission controller in Kubernetes. So admission controllers are sort of this framework within Kubernetes. It's sort of like the last place where policies get enforced essentially in the cluster. So it's where all the kind of like semantic validation of Kubernetes resources occurs before the resources persist to etcd and before all the controllers go off and start doing stuff with it, right? So it's sort of like the last chance that you have to prevent really bad things from happening inside of your cluster. So it's really important to have a good handle on that. And so OPA plugs in as a webhook admission controller. You can run it on your cluster, basically. And so effectively, every time a resource is created, updated, or deleted in the cluster, the API server will make a call out to OPA and ask, should this be allowed or not? And when that happens, OPA will look at the resource, the pod, the service, the ingress, whatever that's being mutated, and it'll decide whether or not to allow that and possibly mutate it. And then it'll return that decision to the API server. So it's a really important piece of functionality because like when you're looking at Kubernetes and you're running Kubernetes in a large organization, you're typically handing it off to, a bunch of teams, app teams, to people that are developing and deploying applications on top, right? And while that's great because it accelerates their development and their deployment, because it gives them the ability to say, run these workloads with this much CPU and this much memory and expose them on these ports and give them this storage and all that kind of stuff, that's a tremendous amount of control and responsibility that's being delegated to development teams, right? And so it's vital that like platform engineers have the ability to put safeguards in place that prevent applications from impacting each other, from doing things they shouldn't on the cluster, from opening up load balancers on the public internet that are going to get accessed, right? Or opening up egress traffic to the public internet, right? There's just this long list of potential risks there that admission control and OPA help mitigate.
So talk about that a little bit more. You mentioned a few, but what are some of the common use cases that people use OPA for with Kubernetes to be able to solve?
We just did an article recently about like the top 5, and I don't remember them off the top of my head. I guess when it comes to pods, and compute resources, people are often looking at ways of ensuring availability and just uptime, right? So they're, making sure that developers are setting liveness probes and readiness probes and setting CPU and memory requirements, properly on their compute resources. When it comes to like networking resources, that starts to get into a little bit more of the security concern and domain, but it's still availability. So like one of the really popular first use cases for OPA around admission control in Kubernetes was to prevent conflicting ingress resources from being instantiated in the cluster. And it just so happened that OPA was a really good fit for that problem and people picked it up and started to use it. But that's more of an availability uptime concern. There's also security, right? Like if you allow your developers to instantiate network policies, they can open up egress traffic anywhere they want, right? And so you might not want an app running on a cluster to be able to talk to any IP address in the world, right? So you can write Rego policies that look, it's kind of cool. It's like a meta policy, right? You're like writing Rego that's looking at these network policy configurations and deciding whether or not those firewall rules effectively are valid.
Some people are going to be thinking about, we're adding one more thing into the request, right? The request path of actually getting things done. everything comes with a cost. What's the latency cost? I know we talked about performance, if things are built for optimized for performance, but is there a cost to adding OPA into the stack like this?
As you say, there's a cost for everything. So the thing we often will talk to users about is like cost benefit, right? Yes, there's going to be a cost, but if you're preventing a bunch of problems that you know are going to bring you down or open you up to security or compliance problems, then it's probably worth the cost. In terms of like numbers, we usually think about the different use cases for OPA as having different requirements around performance. So for Kubernetes, 10 milliseconds or even 100 milliseconds is not usually a problem. If I thought about microservice authorization and somebody was going to say, well, I'm going to put a policy in place that takes 100 milliseconds to evaluate, I would say, no, don't do that. Netflix always gave us a millisecond. If there's a millisecond of overhead extra, fine, no worries. If you think about the CI/CD pipeline, it's probably even longer. Is anybody going to care if it takes 30 seconds to evaluate a bunch of policies over a bunch of data files? Probably not. So that's typically how we think about it. And then the other side of that is that some of these different optimizations that we put in place take advantage of different fragments of the language. We talked about how this language sits between the RBox and ABox and programming languages. Well, even Rego itself, the language was designed sort of as an onion. So there's a core part of the OPA language that will run very, very, very quickly. If you write policies that go beyond that first level, then they'll still go quick and you'll get a little bit more expressiveness, but they won't be as fast as that core. And so then what we do is we work with people. We'll say, yeah, what are your performance demands first? And then we'll help you pick the right fragment of the language to use.
How do I get OPA policies into it? How do I get Rego into here to actually protect things? So how do I introduce policies into my Kubernetes environment?
That's a great question. So for Kubernetes admission control, we have a sub-project called Gatekeeper, and that's sort of our Kubernetes native integration for OPA. And so that allows you to load policies essentially as CRDs. So, you can create some tooling that takes your Rego files and then stuffs them into CRDs, and then those get populated on the cluster, and Gatekeeper picks them up and starts enforcing them. If you're just running plain OPA, then you can just volume mount them in, or you can use OPA's management APIs. OPA has these APIs that allow you to control and observe it. One of those is called the bundle API, and that's basically a way of distributing policies out to arbitrary OPAs, not just Gatekeeper, Kubernetes specific ones, but arbitrary OPAs. You can use the bundle API for that.
Recently, there was news that OPA graduated from the CNCF. What does it mean for OPA to be a graduated project from the CNCF?
So the CNCF, the Cloud Native Compute Foundation that hosts OPA, they have kind of like a laddered model of projects. They come in at sandbox, they go to incubating, and then they graduate eventually. And that process is just about demonstrating that you've satisfied a bunch of criteria, right? And so, the criteria is largely around adoption, right? So basically end user companies that are running the software, and then as well as contribution back into the project, ensuring that there's like a vibrant community of folks that are actively, participating in the project. And then there's a bunch of other kind of, technical best practices that projects need to adhere to, especially around security and, release process and things like that, right? And so we kind of like went through the journey. We joined the CNCF in 2018. And then in 2019, it was promoted to incubation. And then just recently it was graduated because we sort of demonstrated the adoption and contribution and whatnot.
That's awesome. Congrats. One of the things I think I saw at the end of a talk or read a blog post that there's a WASM story around OPA. I wasn't expecting that. Tell me about that. Why WASM? Is it just for performance reasons? But why WASM? Where'd this come in?
There's a bunch of reasons why we're excited about WebAssembly. So if people aren't familiar with it, right, WebAssembly or WASM is this instruction format for virtual machines, right? So it's similar to the JVM, but it's delivering on this goal of like write once, run anywhere. So it's been adopted by all the browsers as well as for these non-web embeddings, right? So people are putting it into service proxies. They're putting it into databases. They're putting it into CDNs. They're putting it into blockchain even. They're using it on IoT, right? And so WebAssembly is really attractive from a policy point of view because it's a new enforcement point that otherwise wouldn't exist, right? So it allows us to basically enforce policies in places that otherwise we couldn't reach. And so what we're doing with OPA is we're basically taking Rego policies and we are compiling them from scratch into WebAssembly. And so what that means is that you can basically take an OPA policy and run it inside of any WebAssembly compatible runtime, right? So this is great for a bunch of reasons. It allows us, for example, to just have library embeddings for arbitrary languages, right? OPA itself is written in Go. So if you don't want to integrate with it over HTTP and you want to embed it as a library, you're limited, right? You can embed it as a library in Go, but you probably don't want to be embedding a Go program inside of C++ program or a Java program. WebAssembly kind of gets us around that because we can just compile up the WebAssembly for the Rego and then run that WebAssembly inside of a WASM library for Java or .NET I just saw this morning that somebody had created a Java SDK for OPA using WebAssembly. So now we've got Node, Go, Java, and .NET. So it's really cool to see that. So it's enabling all these library embeddings. It's getting us into places that otherwise Rego couldn't run in, like CDNs and so on. And then obviously it's great from a performance perspective because it gets rid of the interpretive overhead that the standard OPA evaluator has. And so we've actually gone and integrated a WebAssembly runtime back into OPA itself. So we can now use WebAssembly as like an optimization path within the normal evaluator, the normal interpreter.
So what's the future hold? What's the roadmap look? Now that you've got a graduated project, you've integrated or you're integrating in WASM into it, what's next?
I'll give you some high level thoughts, right? Like one of the things that's been great is the community, right? Like working with all these end users, working with contributors, working with people who are doing integrations with OPA. It gives us very clear insight into what's needed and what to do next. And so like certainly at a high level, it's been fun doing that. And we're going to continue just following the community and doing some of the things they need. But I think, Torin, you've probably got some other more specific things.
On the technical side, there's a bunch of interesting work happening right now around adding support for metadata and schema support. And that's being worked on by some folks at IBM Research. So I'm really excited about that. I'm looking forward to all the tooling that's going to enable around OPA. Feature-wise, we're looking at some syntactic improvements in Rego, adding some sugar to the language in the near future. So that's exciting. The project's been around for a little while now, right? So we have a pretty mature user base. And so we're just kind of continuing to focus on performance and reliability. And so there's a long list of optimizations that we're reaching to implement in the core.
I'll add that metadata feature, the type checking as well, the IBM folks are doing. Those are both pretty exciting because that metadata allows us to put documentation into the policies themselves. And so, we're looking forward to a world where if somebody wants to know like why a decision was made the way it was, then you can imagine getting a text string back that says, well, these 5 rules were violated. And it's not just like the internal Rego rules, but rather they're English strings like a business level user can make sense of.
When we were talking before, you mentioned that there's some like an academy or something out there that people can get access to. Can you talk a little bit about if people are interested and want to get a little bit more, where should they go to learn a little bit more about OPA?
Yeah, there are a couple of good resources, some of which are easier to find than others. So I'll call a couple of them out. You'll find this one from the OPA website, which is the OPA Playground. So that's just linked right there. You should be able to find it. That's a great way of trialing out Rego, editing some simple policies, getting sort of that workflow in your head about like, how do I write Rego policies and how do I debug them? And then sort of complementary to that is the academy. So we put an academy together, an online course that walks through sort of an introduction to Rego. And it's got lectures. I've done the lectures, so you hear from me more. And then there are quizzes as well. I know I need these anytime I listen to something. I'm like, great, yeah, I think I got it. And then you have to actually answer some questions. It makes you check, do I actually understand what's going on? And then we just started adding our first hands-on lab to that as well. So that's really great because then it's not just like some multiple choice questions, but it's like we asked you to go out and write Rego and actually run OPA and feel what that's like. So anyway, we're excited by that. If you want that, that's not linked from the OPA website. So you've got to go to academy.styra.com.
Torin, tell me a bit about the community. And if people want to get involved, what are some good places that you'd love to see them reach out?
Like Tim said, we love the community and it's been great, working with them this whole time. And one of the best ways to get started is if you have an idea for an integration or something like that, where, it doesn't exist today, there's plenty of places where OPA could be plugged in. And so if you have some system and some use case, feel free to get in touch. You can file a GitHub issue. You can join our Slack as well. So if you go to slack.openpolicyagent.org, it's like 4,000 people on there. Everybody's super friendly. You can talk to folks and you can talk about whatever you want to build or contribute. And we'll be in touch. And so GitHub issues is a great place to go. And Slack is another awesome resource. And then in terms of contributions, we're always looking for new integrations and new places where it can be plugged in. So I highly recommend that.
Torin and Tim, thank you for joining us on the InfoQ Podcast.
Very cool.
Thank you, Wes. This was a lot of fun. We should do it again.